Good morning, good afternoon, and good evening to all. My name is Svetlana Giambirini, and I am the training manager of the Delta Plus group. And I welcome you today to our series of webinars, once again dedicated to safety at work. As you know, we are organizing these webinars in order to provide you with more support on current issues in our group, such as the development of our ranges, new product focus, new norms, news. And by the way, several topics have been requested by some of you, and with our team of product managers, we've decided to organize and broadcast for you a series of 10 webinars of approximately 30 minutes each during all this year. So you will be able to participate, of course, by registering in the sessions, by making your inscription when you receive our invitations, as always. This webinar is pre-recorded, but while it is on, you have the opportunity to send us your questions via the chat, and please feel free to do so. And our expert will answer all your questions, of course, at the end of the session by email. Today is our seventh webinar, and it is about the hand protection. It's the second webinar about the hand protection, but this time we are focusing on cut-resistant gloves. And we welcome Alexandre Caballero, our market manager for hand protection products. So Alexandre will be leading this session concerning the cut-resistant gloves. Welcome, Alexandre. Thank you to being with us. And I let you the word, please.
Thank you, Svetlana. So today we will focus on cut-resistant glove. So let's start. So first, as an introduction, I think it is essential to remind the importance of our hands and their protection. You should know that one work accident happens every 22 seconds. 27% of these accidents are linked to the hand protection. In France, for example, hand injuries is the main cause of all accidents treated in emergencies, with more than 2 million people per year. And unfortunately, 1.6% of these injuries finish with an handicap. Then here is a summary. So we will see first what is an anti-cut glove. Then we will see our anti-cut offer in Delta Plus. And to finish, we'll do a practical case. So first, what is an anti-cut glove? To know what is an anti-cut glove, you need to know what is a gauge. So the gauge is a unit of measurement used in knitting. A cut-resistant glove is most of the time a knitted glove, so there is a gauge. The higher the gauge is, the thinner is the knitting, and the thinner is the glove and the dexterity. Gauge range from 7 to 18, and 18 is the thinnest gauge on the market. You can see below some example of our product linked to the gauge. Then, how to choose the right glove? In order to make the best choice for your glove, you must first identify what is the main risk. It may be a cut risk, on which we are focusing today, but it could have been a mechanical risk, a thermal risk, or maybe a chemical risk, or another specific risk. Secondly, it will be necessary to identify the secondary needs. For example, a end user may need, depending on his task, cut protection coupled with thermal protection maybe, or anti-static properties. Here, the work environment is important because it will be linked directly to the type of coating we will recommend. To finish our selection, we will decide with ergonomic criteria such as grip, breathability, dexterity, in order to offer the most adapted product for a task a work environment, or even a profession. So now we will see a few standards. The first one is the EN 420 standard that covers all gloves. Each glove placed on the market must meet this standard. So this standard was revised in March 21 to become the EN ISO 21420. So what is changing? The first point is that we must put some more additional information on our product in the label. So there is the batch number for better traceability and identification, the production date, and the obsolescence date, which is automatically linked to the production date. The obsolescence is 5 years for coated glove, 3 years for disposable glove, and there is not any for uncoated glove and leather glove. Then, the antistatic properties of the gloves must be now tested according to the EN 16350, which is now the specific method for glove. So previously, in the past, glove was tested according to the standard for clothes, which was the EN 1149.5. Then finally, some level or harmful products have been revised downwards, such as DMF and nickel, for example. So now we'll make a reminder of the EN 388 standard and its evolution from 2003 to 2016. So as you know, the mechanical standard EN 388 is present on all gloves except disposable glove, and there is an evolution since 2016. So first, the paper for the abrasion test is more abrasive. Then we have two additional tests. The first one, the cut test for the EN 388, is stopped at 60 cycles. If the regular blade is damaged, then the cut test is carried out according to the ISO 13997 standard. The cut-resistant glove level changes from numbers to letters if the new test is carried out. This level range now from B to F, F being the level of cut protection, the highest according to the EN 388. The last point is the impact. So there is an impact test according to the motorcycle standard. The resistance of the glove is tested following a drop of a weight of 2.5 kilos with an energy of 5 joules. If this fails, there is no marking. If it is successful, we put a P on last position. So now we'll share with you some videos to see better what the test looks like. So the first video will be for the impact test. So this is the way we make impact test. Then I will show you another video. So this is the anti-cut test according to the whole method. And if the blade here is damaged, then it will be an anti-cut glove. So we will use the new test, the TDM test. So this is a machine to make the TDM test. Here we put an energy in Newton on the blade according to the level we want to try. So now I will go back to the presentation. Okay, so the right level of protection for the right use. We saw before that the level of protection are run from B to F. Here are some application and some example depending of the level. You should also know that the market is focused on level B, D, and F. We can consider that level C and E are intermediate level, even if they're still important. Now we see the difference between the European standard and the ANSI standard, which is American. So we have to keep in mind that the EN 388 is an European standard. But there is also the ANSI, which is an American standard. We can see here that the ANSI standard is used all through America, the American continent, and then the EN 388 is used in Europe, but also in Asia and Australia. It is also used in South America, combined with the ANSI standard. The test methods are not the same, so you can find differences in level from one method to the another one, but you can still find matches. A level B is equivalent most of the time to an ANSI A2 level, and a level C level is equivalent most of the time to an ANSI A3 level, etc. Then we will see our marking in Delta Plus. So this is a marking we will have. This is an example of the marking we have on our cut resistance glove. So in order to make marking easy and intuitive and to meet the demand and the requirement of our distributor or end user, we decided to put this kind of marking on our glove. So the first point is a standard, ANSI and European. So it will be easier to sell and to control. Then we have the TDM information for a better identification of the level of protection. And we have both sizes in Europe and USA. So it will be easier for inventories and also for the end user to replace the glove. You will be able to find other marking inside into the label. So now we will focus on our offer in Delta Plus. The first one, we have to see our liners. In Delta Plus, we have 5 kinds of liner. We have the Eco No Cut, which meets the standard of the market, and they always sold by pack of 3 pairs. Here you will find some PU and some nitrile as well. Then you have the Soft No Cut. We will also find some PU and nitrile foam. Then you have the Heat No Cut, which is a liner made for heat contact resistance up to 100 or 250 degrees. Here you will find some latex and not any coating on gloves. Then you have the Delta No Cut, which with a good quality, and you will also find some reinforcement and long cuff for better protection on these liners. And then the last one is the Extreme Cut liner, which guarantee a F protection level at the cut resistance. Then we'll see our coating. So we have PU. In PU, you have basic PU and solvent-free PU. So the basic PU is microporous and very elastic with a good breathability. Then the weak point is the weak resistance to oil, greases, and hydrocarbon. And another bad point is that we have DMF on the basic PU. If we compare basic PU to solvent-free PU, there is not any DMF on the solvent-free PU. Then latex is very soft and elastic, robust, waterproof to alcohol and detergent, and has heat resistance properties. There is also a good grip on latex. The bad point is that latex is sensitive to UV rays and can give also allergies. And then you have the nitrile. Into nitrile, there is nitrile, smooth nitrile, and nitrile foam. So nitrile foam is much more breathable than nitrile smooth, and there is a better dexterity, but the price is higher than nitrile smooth. Then we will see our additional spec on our items. The first one is a reinforcement for better durability and longevity of the product. Then we have the long cuff that protect arteries. And you have to know that we use the same fiber for our cuff. So you have the same level of protection that you have on the hand. Then the touch function for a more versatile use. And this allows workers to keep the glove all day long if they work on tablets. And then you also have the multi-standard. So this is to make an economy of scale for buyers. And this allows people to not change the work every time if they change the task. Then we focus on our PU range. So you have all different levels, and as you see, there is not so much glove into level C and level E because we focus, like the market, on level B, D, and F. So this is for PU. Then you have the smooth nitrile. So here you have our EOS also, VV910 and VV913 with impact. Then you have our nitrile foam glove. And then you have our other coatings. In other coating, you will be able to find some leather. You will be able to find some glove without any coating as well. And now to finish, we'll make a practical case. So we are going into a car factory. Into the factory, we talk with the quality manager and also the responsible for the production and after-sales service. So what are they doing in this car factory? They handle metal parts, hot metal parts, 80 degrees maximum. So there is a low risk of cutting in a dry environment, but workers burn themselves with a piece of hot metal. So it is 80 degrees maximum. Some employees are allergic to latex. So this is the information we got from the quality manager. Then we talk also with the responsible for production and after-sales service. So he said that he has some bad feedback regarding the body paint of the cars that are deteriorating. Then also we have some issue with electronic parts sometimes that are not working at the end of the chain of production. And also some employees work on tablets. They always remove the glove because the glove doesn't work on tablets. So with that, this is how we do. Here, for the 80 degrees pieces of metal, we'll need heat contact resistance. 80 degrees, so we'll need a level 1 minimum because level 1 is up to 100 degrees. Then, regarding the allergies, we will have to use a glove without latex. For the cut resistance, according to what I say, a level B or level D should be enough. Regarding the body paint of the car, we should not use any silicone because silicone can alter the painting of the car. For electronic devices, we'll need the glove with anti-static properties in order to touch the electronic devices. Then for the tablet, we have to use a glove with a tactile function. So this is our solution. it will be Venicode B05 or maybe Venicode D05, depending on the cut protection requested. So here we have the anti-static standard for electronic devices. Then the heat contact resistance 100 degrees should be enough. We have the K-touch function to work on tablet. And we have also a glove solvent-free with no silicone for the painting, no latex for the allergies. So from my side, this is finish.
Okay, thank you, Alexandre. Thank you for this great explanation, for this presentation, and also the risk assessment, which is very useful, I guess, for everybody. So I hope it will help to clarify the topic for all of you. And thank you all again for your attention. Thank you for being here with us. And of course, we will answer all of your questions after the webinar as promised. And we look forward to seeing you at our future sessions. We will keep you informed about the new topic in the next episode. So, see you soon again. Thank you, Alexandre, once again, and bye bye.